So now we're going to go into our final exercise of our tutorial. And now that we've talked about kind of the inner workings of these self-attention modules, what we really want to get at is what are these self-attention mechanisms especially good at learning? So in the next exercise, we're going to redo some results from this paper, Inductive Biases in Variable Creation and Self-Attention Mechanisms by Edelman. And we're going to talk about how these self-attention heads, based on this key query and value vector framework, are really good at learning sparse functions. And so what are these sparse functions? So mathematically, these are defined as some t binary inputs, which we'll define as our context length. This you can think of also as a time vector. And there's some s pre-selected unique indices, where the sequence is labeled as true if all of those pre-selected unique indices are 1, and otherwise it's a false. So you can think of this as a 3-sparse AND function, where we need all 3 of those pre-selected unique indices to be a 1 for that entire sample to be true. So this is basically a very mathematical concept that I described, but let me give you an example of something that you could wrap your head around. So imagine an attribute vector that describes basically a thing on Earth. And so if I wanted to ask you how to describe something that was living on Earth, you could give me 100 million different ways to describe them. And those could be different based on if you're talking about a sequoia tree versus a coral reef. And so we could create a whole list of different things, like if it's alive, if it can walk, if it's green, if it can stand, if it can swim, if it has wings, right? And each of those different features might be true for certain things in the world that are alive. However, there are 6 features that would be enough to characterize all living things, specifically growing, reproducing, metabolizing, excreting, respiring, and reacting to the change in our environment. So this is something that we're taught in our early biology classes, but what I want to show you is that this is something that a self-attention module could learn really quickly by itself, given its inductive biases. So these are what these sparse functions are, where you may have a huge list of different attribute vectors, but there are only a couple select sparse vectors that are really representative of the whole data set. And so again, you can take that function and return basically whether the thing is alive or not using the self-attention module. And instead of a 6-sparse function, we're going to be talking about a 3-sparse function. And while the paper had a 3-sparse function, we're actually going to simplify it even more for you in the exercise and give you a 2-sparse AND function, where again, you have some context length and some samples, but you only have a 2-sparse function, where if 2 bits are on, then it becomes a true vector. And this is really just an AND function. And so again, this is just a visual of what these would look like. But what we really want to do is now compare this to something like a multi-layer perceptron, where you have all of these feed-forward connections and no real inherent inductive biases to learn some sparse function. So what we want to do now for this final exercise is to create a training and a validation data set for our multi-layer perceptron and train that multi-layer perceptron model on this task. Then we repeat this for the self-attention model, and we can compare the results for the 2 models and data sets, and we can look at how quickly they learn and how well they learn this task.